Virtualization. I'd like to invite Shane TOVEN to come up and make his presentation. Thank you.
All right, thanks, Terry. So virtualization, it's one of those things that I've been hearing a lot about lately, and you know, the IT industry has been taking advantage of for many, many years, but it's just now starting to find its way into kind of audio and broadcast applications. So I'm going to talk about some of those applications. I'm going to talk about, you know, kind of give a high-level overview of what virtualization is all about, how it can be implemented, things like that. So let's talk about first, what is virtualization? It's basically a method for using a common set of hardware to run multiple isolated machines without having them interfere with each other. So imagine you've got this whole room full of Dell PCs or whatever, all these machines scattered around your facility. Well, basically imagine all of those functionally acting the same way but consolidated into one common, really robust set of hardware. And we'll talk about that a little bit later too. That brings with it a lot of advantages. What it's not is solely relying on the internet for your infrastructure. I mean, it depends on the implementation. There are some implementations that do rely on some internet connectivity, but not always. It doesn't have to be that way. I think that's one of the big fears that a lot of people get into when they start thinking about virtualization. So you'll hear the word cloud versus virtual and all this stuff a lot. I mean, the two terms are related, but they're not entirely interchangeable, okay? So virtualization is a technique or a tool, whereas cloud is more of an architecture or an implementation. So it doesn't necessarily rely on any sort of outside connectivity, as I said earlier, but it can, in some cases, be just a completely standalone internal system. You could have one box completely inside your facility without a whole lot of external connectivity, virtualizing a whole bunch of other systems. And it doesn't have to rely on the internet at all, other than what your applications would normally rely on the internet for. Cloud often does rely on connectivity to the internet, but doesn't necessarily need to in some applications. And I'll get into that in just a second here. So let's look at the types of virtualization. Three basic types. You've got on-prem. That's basically hosted entirely on-premise inside your facility, okay? It's user-owned equipment at the user site. You control the horizontal, you control the vertical. It doesn't necessarily need to rely on any outside connectivity for normal operations, and it can be completely standalone infrastructure in some cases, okay? Private cloud, very similar, but it consists of dedicated resources shared outside of your local network, but still controlled by you. I mean, that may be some resources that you have out in a data center, for instance, somewhere. Maybe not necessarily on your local facility, but somewhere, but you still control it. But it's your own kind of private implementation. Public cloud is more like services like Google, AWS, Azure. It also includes those publicly hosted application services like Office 365 and Google Workspace. Okay. Some of the applications for virtualization, almost anything that you can run on a system can be virtualized. Okay. So all your back office and operations type stuff, automation systems, if you're a broadcaster and you have automation systems for playout, that can all be virtualized. Pad generation and routing, that's metadata basically. All that metadata generation and routing could be virtualized on a system. Your audio processing, so you got a bunch of plugins. Say you want to run those or share those and put those on a common platform. You can do that in a virtual environment. Remote control and monitoring, and again, this is more for the broadcast side of things, but monitoring of your facilities can all be done in these virtual stacks. And finally, audio transport between facilities can be done in a virtual realm. So traditionally, we've had those hardware codecs, right? Like some of you probably remember the old school days, like the Telezephyr and stuff like that, ISDN boxes transporting audio back and forth. Well, you don't need a box anymore. Your virtual stack is the box. And I think of it, here's the best comparison I can make. Think of it as your rack, okay? But it's basically all inside of this, this virtual software realm now. And for the broadcast applications, there's a term for digital radio, HD radio. The software that generates those signals can also potentially be virtualized. So some of the benefits here. It can allow for a substantial consolidation of hardware. So remember I talked about having all these machines scattered over your facility, utility machines doing all these different things, right? They're a headache to manage. You have to go to every single one and do updates manually, and it just gets to be a real headache to manage. So being able to consolidate that will allow you a lot easier management and potentially a lot more reliability and less cost of operation. So it can potentially reduce your downtime. So you can have multiple instances of these virtual machines, kind of one in a cold standby state and the other one online. So what you can do is you can update one of those instances kind of offline before putting it in production, switch that to your online production once you're satisfied that it's up and running and working and tested, and then update the other instance. And then you've got both of your instances updated, and you had nearly zero downtime in doing so because they're just kind of there, sitting in the background, waiting to be activated. So, like I said, a lot of operational cost savings in terms of not only time and labor and energy in maintaining the systems, but also potentially in electricity. Again, one nice common set of really robust hardware is probably going to consume a lot less energy than a bunch of boxes scattered all over the place, or racks and racks and racks of servers for dedicated purposes. So, and it gives you a single point to manage all of this stuff. So, for instance, again, instead of traveling around to every single one of those boxes or using a KVM switch or something, you can now manage all of those systems from within a browser from almost anywhere. That, for me, was the real draw right there, just being able to access all of the consoles on all of those systems from a web browser from anywhere. And it allows better sharing of resources among your team. Because now, again, you've got that common shared resource instead of a bunch of stuff scattered everywhere. And finally, it lets you leverage the experience of people who have got a lot more time and experience in maintaining these things, like the Microsofts, the Googles. The IT industry, like I said, has been doing virtualization for a long time, and we as kind of audio professionals, broadcast professionals, are just now kind of dipping our toes into it. But going this direction means that you can tap into that great base of experience that's out there and kind of have that, have that base already there to kind of support you as you build your infrastructure. Okay, so there's never such thing as a free lunch, right? There are always drawbacks, no matter what you do. There's, anybody who tells you anything is the greatest thing since sliced bread, but doesn't tell you about the downsides, well, you better think closely. So one of the biggest ones is that these public cloud designs that I mentioned earlier that rely on internet connectivity, they're only going to be as robust as your last mile connectivity. I know our last presenter talked about collaboration back and forth. Well, those types of applications are only going to be as robust as your local internet connectivity is on site. Okay, and that's just kind of the nature of the game, unfortunately. And there are always the risk of outages for any given kind of major cloud service provider. Microsoft Azure, AWS, from Amazon, Google, they have all suffered pretty major outages at some point or another, and in not too distant history, actually. I mean, even this past year, there have been a handful of outages on these services. So, and doing your own on-prem deployment, again, depending on how complex it gets, can require a little bit more specialized experience, okay? If you're just deploying, one or two boxes for a virtualized environment, okay, that's not a big deal. You can probably figure your way around that pretty easily. But as you start clustering things and getting into shared storage and all these other types of infrastructures that can host a virtual stack, then you might have a little bit more experience required there. But again, as I mentioned earlier, you can leverage some of that experience from the existing IT industry to kind of find your way around that. And then finally, the biggest drawback is the all your eggs in one basket scenario, right? This is, again, one of the biggest questions I get is, well, what if this fails? Then I've lost everything. Well, yeah, but you can design around that. You can design to make your system as robust as your budget and your tolerance for risk will allow. So some of the hardware considerations here, the cool thing is you're able to do this on just about any available hardware that you have, right? It doesn't require some massive, really high-end server cluster, running to do this. It's really just kind of primarily depend on the requirements of your applications. So you look at what your applications would require if they were on a standalone box, for instance, okay? You kind of take all of those into account and you go, okay, so I'm going to need at least this much RAM, this much storage, and about this much CPU horsepower to host all of those applications in this virtual stack. And that's really the biggest thing. But I mean, it's just as far as just playing around with it. I mean, you can load this. You can load up a virtual stack on any garden variety old PC or laptop that you might have laying around, just to play around with. So some of the advantages here, again, scalability. So when you have a virtual stack, these virtual systems, they allow what's called clustering. So you can actually scale up if you need more power to, or more redundancy. You can scale to a larger hardware base. So you can do all the way from a single system running multiple virtual machines for one site or a small business, for instance, up to these massive systems running large enterprise applications. Okay, so it's not like a one-size-fits-all kind of thing. You really can just design it for whatever your exact needs are. Resiliency, it can be made as, again, it can be made as redundant as your budget and your tolerance for failure allow, okay? You can go really, really simple, just a single machine, a single hard drive, you know, probably not a great idea to do it that way. Or you can go up to these massive clusters of stuff like, you know, like Cisco UCS or any of these other blade server type environments that you might be out there that you could deploy. And multiple nodes, as I mentioned, could be clustered together to give you some fault tolerance. So say you've got one node here that fails. You've got another node over here ready to kind of pick up the load right where this one left off, and then you can deal with whatever happened on that node. And if you've got three, even better. I mean, a cluster of 3 nodes is going to be really, really hard to bring down from a hardware perspective. So, and you can also, again, set up storage so that you can share those among all of those nodes in the system and set it up in a fault-tolerant way, just like you could any other standalone storage system on a PC, like RAID or you know, whatever your flavor is that you prefer. You can do storage area networks, things like that. It all works really well for this as well. One of the really cool parts, though, is that you can take snapshots of these virtual machines, and then they can be captured at any time and stored offline for recovery or for cloning virtual machines. So say you get hit with ransomware. You did have some snapshots backed up, right? They are offline somewhere, right? And they are relatively current, right? Okay, but there are a lot of strategies for dealing with that. But the fact that you can just literally, you know, have a few clicks and spin up another machine exactly as you had it configured before, I mean, that's really pretty cool. So what makes this all possible? It's a piece of software called a hypervisor, a very specialized piece of software. There are 2 types, basically. The first type is a type 1 or a bare metal hypervisor. So that's basically a specialized operating system and a virtual machine host that runs directly on the bare metal machine, okay? Virtual machines will share whatever resources are available on that hardware or within that hardware cluster. And this type is really good for hosting dedicated servers and applications, okay? So if you've got a stack of applications that you know are going to need to be available 24/7, 365, you'd probably put them in this type of environment. So some examples of that. The other cool thing is if you've got specialized hardware that you need to access on one of these virtual machines, you can put that in the actual box and then pass it through to whichever virtual machine might need that piece of hardware, whether it be a PCI card, whether it be a USB device, anything like that. There's also this really cool thing, software licensing dongles on USB are pretty common, right? So how do you do that in a virtual environment? Well, there's this really cool box, and I'll get into this a little bit later, called a dongle server that will basically take all of those USB keys, put them in a secure enclosure in your rack, make them available on the network to all of these virtual hosts so they can access their license keys. Pretty cool stuff. Some examples of some of the type 1 hypervisors would be Proxmox. That's one that I like to use. It's fairly easy to spin up. It's free, all the better. You can get commercial support for it, and that's where they charge for it. But there's also VMware, so you'll see that in a lot of really big enterprise type applications. Huge learning curve, huge cost, but in some cases that's the right tool for the job. It just really depends, again, on your budget and your comfort level. So again, with the bare metal hypervisors, they give you a virtual KVM access to systems through a web interface, and that is just super cool in my book. You can access them through any standard means, whether that be SSH, RDP, or even better yet, so say you've got a studio, right, and it needs to connect to the resources on one of these virtual machines. You need a keyboard, monitor, and mouse in your studio. Okay, so how do I do that? Well, there are these devices called thin clients that you would put in a studio. Basically, all they are is almost like a dumb terminal. They've got a very minimal set of resources on them, just enough to connect back to this cluster and present the user interface to the operator in that particular room. So the other type of hypervisor is type 2. It's a hosted hypervisor, okay? Now these will run under an existing operating system. So like if you've got a Mac, for instance, I mean, I don't know how many of you probably Mac users got the M1 or M2 Macs, right? Parallels, for instance, that's a type 2 hypervisor. And you can load up Windows on there, it'll work great. You can load up an instance of Linux on there, it works great. These are great if you want to kind of sandbox an application or try a new operating system without removing your existing one, okay? So this is kind of, I mean, if you wanted to learn Linux, for instance, but you didn't have another machine to put it on, okay? Load up a Type 2 hypervisor, for instance, VirtualBox for Windows or Parallels for Mac, and go to town. And you're not destroying your original machine. You just have to make sure you have enough disk space for whatever you're trying to do. And of course, memory. All right, so the other thing that you'll hear about in this subject is containers, okay? Now, containers versus virtual machines, a virtual machine is exactly what it sounds like. It's a fully functioning system, complete with the operating system, all the applications, everything, just as a traditional server or PC would have, right? Okay, containers are more like these applications that you would load up in a virtual environment. The difference is that they aren't really a full operating system, okay? They rely on kind of a base system to manage them. All these containers have in them is the binary for the application and the config files and any other support files that might be necessary for that particular application. They could host anything from these tiny little microservices. Like if you're playing a game on your phone, I can almost guarantee you it's talking to a container somewhere out there on a cloud, hosted on a cloud service. So some of the common management platforms for containers are Kubernetes and Docker. Docker is pretty popular because it's a little bit more lightweight for smaller scale operations. Kubernetes, that takes it to a whole new level. That's, again, enterprise grade, really, really high-end type stuff. So one of the advantages to these containers is that if they crash, they don't really affect anything else on the system. Okay, because it's just that application in just that container and its own resources. It's not relying, like on Windows, you have DLLs, right? So it's linking to all these DLLs in the system, and if it crashes, it might just take that DLL along with it and anything else that's relying on that DLL. Well, that's the whole advantage to containers, is that they don't really have that issue. They can also be scaled up and down a lot more easily. Because you're not building a full environment for these containers, you can add them to handle additional load or scale them back down. For instance, like if you're using a service like AWS, you don't want to have more capacity than you need to, but you want to have enough to handle the load. I mean, AWS, for instance, if you're doing your cloud-based implementation in AWS, it can get expensive in a hurry. So you want to make sure you can scale that as you need to. One of the drawbacks is that they might not necessarily be suited for certain things that require a full operating system. Like certain applications, they do rely on all of those extra DLLs that Windows provides or whatever. The other drawback is that sometimes the networking within containers gets a little bit wonky because you've got the application, then you've got the application hosting the containers, and then you've got your hypervisor. And then from a container to talk to a container, they have to go through those levels and then back and forth, and then out to whatever network resources are actually available in your system. So that can cause some confusion and really requires some careful planning. Let's give some examples here. These are a couple of deployments that I did for my transmitter sites and for some studios. Let's start with a really large-scale broadcast implementation. My employer has about 1,040-something signals across the United States. We've got studios located in Rockland, California and Franklin, Tennessee. And they've spun up virtualized clusters for all of the studio stuff, both in Franklin and in Rockland. They can back each other up as need be for disaster recovery and so on. So here's an example of like what we've done here. So yeah, the entire broadcast infrastructure, including playout automation, audio codecs, streaming audio encoders, audio processing, virtualized for last I counted something like 17 audio services, feeding over 1,000 signals across the country, and a similar number of regionalized web streams for those signals. So the platform is Cisco UCS hardware running VMware, again, pretty big iron stuff in this case, and an HP storage system shared among all of the nodes in that cluster. Lots of high-performance Cisco networking connecting it all, and mirrored redundancy between the two locations in case of disaster recovery. Okay, so here's kind of what that looks like. At the very top, you can kind of see our Lantronix kind of master clocks providing PTP for everything. Remember, audio over IP, I mean, you've got to have media over IP, you've got to have a nice clock source, and that's what that's doing for us. There's the dongle server I mentioned, that big blue box right there. You can see some of the networking, and then the big green front thing, that's the HP storage system. And underneath that is the actual Cisco UCS chassis. It looks like that one's got 5 nodes online at the moment. So it's handling quite a bit of stuff in that little space there. Okay, so how do you actually get stuff in and out of there? Well, in our case, we've got nodes. In this case, it's Axial Livewire nodes that are providing the audio in and out of the virtualized system. It's all being really mixed and handled otherwise in that virtual stack, but you've got a console engine at the top, you've got the nodes for audio I/O, you've got an intercom panel, a bunch of networking and patching up at the top. These studios themselves don't actually have any equipment in them other than the console, the microphones, monitors, and like I mentioned earlier, the thin client and screens for that stuff. That all resides back here in the tech core. Because in this case, there really wasn't room in those particular studios for that equipment, so it was all brought back and kind of centralized here. So you can see all the patching up there for that audio I/O. Now let's look at a really small scale remote implementation. These are those single individual transmitter sites that I mentioned earlier. Okay, so in my case, audio processing, remote control, and STL, or studio to transmitter link between facilities. I've got it deployed right now in American Samoa and the U.S. Virgin Islands. I don't know what possessed me to deploy this stuff at my 2 farthest flung stations, but I did. So here's what one of our standard racks would look like. Okay, so you can see a number of components there, and about, I would say, 2/3 of that rack right now could be combined into a virtual stack. So that's considerable savings there in terms of the cost of the equipment and just having all that stuff hanging out there. So like for example, in American Samoa, I was on site, I had an audio processor fail, and I needed to get something on the air. Well, okay, I happen to have this box here. It's really not that big, it's really a pretty modest machine. It's in one of the old, remember the Atom processors from Intel? It's just basically an old Atom 1RU box. So I loaded up Proxmox, I loaded up an instance of an audio processing software, I loaded up the remote control software, and away we went. I mean, it replaced a whole bunch of components. It replaced an old microwave link that sounded really bad and now is IP fed and sounds really clean. Same thing in the Virgin Islands. So you can see these are the only components that really couldn't be virtualized in this particular case. We've got some RF monitoring there at the top, a satellite receiver under that. Technically, we could get the audio over IP directly into the virtual stack, but that's the platform we use at the moment for audio. Another node for kind of managing some audio, what's called the emergency alert system underneath that. Again, one of the few components we can't virtualize, not because of technical reasons, but regulatory reasons at this moment. The transmitter, and at the very bottom, you can see kind of peeking out there the pizza box. It's an old kind of HP server of some variety. I forget exactly what it is, but it's not anything really spectacular. But it's on the air and it's working, and it works great. So again, that's all our processing, remote control, and encoding for the transmitter's audio. So, I mean, if this stuff can work reliably on a small island in the middle of the South Pacific, it can work literally anywhere. And me, probably, or something like that. Okay, that's great, but how do I get my audio and control in and out of the box, right? I mean, you still got to have physical I/O, even if all your software is virtualized in a stack, right? Every engineer who's tried that, probably. All right, so you can use what's called SNMP for remote control. That's Simple Network Management Protocol. It's one of many standards that you can use for control. You can use any flavor of audio or media over IP for audio I/O, whether that be AES23, whether that be SMPTE 2110, whatever it is. I mean, you can get it in and out over the network. And then for the audio, there's a standard called Micro MPX for delivering the composite audio input to the transmitter, or for stereo transport, or for studio transmitter link transport. So how can I try it? Find an old server, load up Proxmox. Or if you want to just use, experiment on a machine that you've already got, load up something like VirtualBox. Go ahead and install your first machine. Create the hardware that it needs. So you always have to define what resources that virtual machine is going to have available to it in terms of hardware. Fun fact, you can actually oversubscribe the physical hardware on your box because those virtual machines aren't necessarily going to all need the same resources at once. So yeah, go nuts. And then, yeah, I mean, sky's the limit. You can play around once you've kind of discovered how much easier that can make life from an infrastructure perspective. I don't think you'll ever go back to one box per purpose. That's no longer in my vocabulary. I'm no longer deploying individual boxes per purpose. Well, I mean, that's about it. Actually, I think I'm right on time. That's amazing for me. Questions?